Hi chemistry peeps, this is just a short video about stoichiometry practice just to check and make sure. On your stoichiometry practice, number 1 was pretty easy. You just had to start with 2.8 moles of HCl and then multiplied by 1 mole of H2 over 2 moles of HCl, which equals 1.4 moles of H2, which I've got up there. Number 2 should be 150 grams of CO2. Number 4 should be 94.8 liters of oxygen. And then I've worked number 3 out here because it has scientific notation in it. And so it gets a little strange. So if you follow your stoichiometry map, then you know, well, regardless, you start with what you know, which is 1.3 times 10 to the 24 molecules of NH3, because that's what is given in the problem. Follow your map. 1 mole of NH3 over Avogadro's number of NH3, 6.02 times 10 to the 23. And then here we have our coefficients, and I've left those blanks. I want you to look at your equation for number 3, and you'll see in the equation H2 has a 3 in front of it. So that's where we get a 3 for the moles for H2. And when you look at NH2 in the equation, you see a 2, so that's where that comes from, okay? And then the last step is to do your standard 22.4 liters, because it's standard temperature and pressure. That's how much volume a gas has, and that goes over 1 mole of H2. And our answer is going to be in liters of H2. So let's see how we solve this. So when you what you do, since we can't cancel out this scientific notation, if I had an Avogadro's number up top, I could cancel those out, but I don't, so I can't do that. So I'm going to take this 1.3 and I'm going to multiply it by 1, then I'm going to multiply it by 3, then I'm going to multiply it by 22.4, and that should come out to be 87.36. Okay. And then I'm going to take the 6.02 and multiply it by 2 and by 1, and that should be 12.04. Okay? Now when you divide those, you should come up with 7.25. Now, that's not the final answer because we're still got our times 10 to the 24 and our times 10 to the 23, okay? So what you can do is when you have this, you take this exponent, 24, you subtract this exponent, 23, from it, and you get 1, okay? And that's a positive 1. So if it's a positive 1, I'm going to move my decimal to the right. Okay, so I'm going to move this decimal over here, and it's going to be 73.5. So that's my final answer. Okay, hope that makes sense. So when you have a positive exponent left over, you move it to the right. So if you have a negative exponent, then you move it to the left. Okay, so the final answer for number 3 is 73.5 liters of H2. Hope that makes sense. Let me know if you have questions.